Hi. So, look, when we were examining logarithms and exponential functions, thus far, we actually been using 2 as our base in the examples because it's convenient to actually calculate everything when the base is that simple. But of course, as you remember from the math class, this is not the base we like the most. We like the most the bases with e. Base with e makes very simple derivatives, and derivatives is something we will be interested in very much, as well as, of course, integrals are easier to calculate with natural logarithms and natural exponential functions as well. So, in the next couple of videos, we will put way more attention on e as being our preferred base. But before we do so, let's just remind ourselves a little bit what e actually is. Usually when I ask students, the answer I get is that e is 2.72 approximately. And of course, that is true, but this is not the answer to the question what is e, but rather how much it is. And I know that we did something similar in our mathematics class, but let's review what is e all about. Okay, and in order to do so, we will use a very simple example with capitalization of interest. Okay, so imagine that you got $1. This is your capital. Then interest rate at a bank is very nice, 100%. Which of course, remember, when we have 100%, we can write it as 1. Then, let's just say that this interest rate is associated with putting your money into a bank for 1 year, and we are going to keep this money in the bank for 1 year. So, the question is, how much money will we have at the end of the year? Let's denote the sum by v. Well, we will definitely have our initial dollar, so we need to multiply this $1 by 1. And now we need to add something. Well, we should get another 100%. So, just 1. And we can clearly see that at the end of the year, we will have $2. Okay, but let's just say that the situation changes slightly. We still have $1, but the interest rate falls to 50%. But this fall is not that bad because now you get 50%, but for half a year, which means we will have 2 capitalizations. Now, of course, we can write 50% as 1/2. This is simply half. So, how much money will we have right now? Well, let's figure this one slowly. So, v is again $1. And what is capital? We will certainly maintain this amount of money, and we will get 50% extra. And look, if we calculate this out, we see that after half a year, we have $1.50. But now we are maintaining the money in the bank for another half a year. But now the amount of money we've got is bigger. So we multiply this amount of money by the same expression again. And it turns out that after 2 years, after 1 year, we will have $2.25, right? But we see see definitely some pattern over here. So let's maybe write this differently. This repeats. So why not write $1 times 1 plus 1 over 2 to the power of 2. And I think at this moment things should start coming together. But of course, let's go even deeper. What if you've got $1 and at the same time interest rate in the bank drops to 25% or 1 over 4, but now this is a quarterly interest rate, so we will have 4 capitalizations. Now, if we want to calculate how much money will we have at the end of the year, all we have to do is to use basically the same line of reasoning we used over here. Well, we start with $1. At the end of the first quarter, we will have this much money, but there are 4 quarters, so we need to take this expression to the power of 4. And we get that this is approximately $2.44. Okay, but what if we would have a monthly interest rate this time? And this monthly interest rate would be 1 over 12, and we would have 12 capitalizations. Well, again, we can use the formula to find out the answer. And the answer in this case is actually $2.61. Okay, let's pause for a second, and we definitely see some patterns to reappear. The pattern is that capitalization works in such a way that it is better to have lower interest rate but more capitalizations. But as you see, the value of the amount of money we will have at the end is not growing very rapidly. Actually, we see that it actually grows slower and slower. First by 25 cents, then by 19 cents, now by just 15 cents. So let's maybe see what's going to happen if we will continue with that. Okay, so next possibility is not just say this. So what would happen if we still have $1, but interest rate is 1 over 365, but we have 365 capitalizations. Again, we would just use the same formula. And 365, which gives us approximately $2 and almost 72 cents. Right? Okay. Now if we multiply number of days by the number of hours, we can do it on hourly basis. So, if we would have $1, interest rate would be 1 divided by 365 multiplied by 24, which is 8760, and we have 8,760 capitalizations. Again, we use exactly the same formula. And we are getting that this is approximately $2 2,718. Well, now, when we look at it, we see that the increases are even smaller than before, and we could see that this value is stabilizing at some level. Now, if we remember that E is approximately 272, we see that this is exactly what we are getting. We are getting numbers that are getting closer and closer to this almost 272, but we would never reach before. And look, remember in mathematics we discussed limits. Limits is basically is a concept that is telling us what is happening to the value of the function as an argument approaches some specific value. What is interesting to us in this case is the limit, let's just say with some n approaching infinity. Okay, what would be the situation like this in this context? Imagine that there is some extremely small, tiny interest rate, but the bank adds interest at every possible moment, at every nanosecond, or actually even smaller and more frequently. But this is what you need to imagine. So look, now we have a situation when bank is adding up interest every possible moment, but the interest is really tiny. You could describe the situation as that. How much money will we have at the end of the year? This much. Which is, of course, approximately $2.72. Okay, this is how we get a number. Of course, the official proof for all of this is a little bit much for the scope of this class, but we will talk a little bit more about E in a couple of next videos, because as you will see in this class, its applications to economics and finance are just tremendous. Okay, I hope you enjoyed it.